No it don't! No it don't!
So I want to do part 2 with you, and I will go get you straight on how to do part 2. The key to doing optimization problems, remember, is again, 2 equations. You always have to have 2 equations. The first equation is a max-min equation. And you normally get that from reading the question. The second equation is called constraint equation. Constraint is what limits you. And this next example is the one that's used a lot in the industry, in manufacturing. Here, grab your package out, please. It's example 4 of the package. So I'm going to show you how this is done. So grab your package out, and what we're going to do is we're going to do this question right here. It says you want to construct a box with a base length that is 3 times the base width. The material used to build the top and bottom costs $10 per square feet. In reality, that's exactly what's going to cost when you build the boxes. The material used to build the sides costs $6 per square feet. I want the volume to be 50 cubic feet, dead on. What is the dimension that will minimize costs? If you were to guess and test, I guarantee you it's going to cost you a lot of money in the end. I want to know what dimension will give me the lowest cost. Now the answers are here. Okay? These are the answers. Problem was, how did I get these answers? Come up with one. I'm going to pause and give me my max or min equation. This is the hard one. You may want to wait until I get to here, but you should be able to do the constraints on your own. Constraints. Okay? My advice to you is start with the constraints first. That's probably the easiest one. I'm going to pause it. Let you have fun with it. Go. Does anyone have a constraint yet? I don't have a constraint? No constraints? Wow. Let's draw a box. So, whoa, my box is weird. Okay, let's just draw a simple box. I want to change the thickness of it. Okay, so let's draw a simple box right now. Here's my box. Very, very simple box. Okay. Now, I want the box to have exactly 50 cubic feet. So this box, but it says one more thing. The base length is 3 times the base width. So why don't we call this the width? Okay. So if that's the width, you need to label this line right here. 3W. Very simple. See, there's no tricks to this. Only trick is can you understand the words into numbers? And then, problems, let me ask myself, what's this height? I don't know the height yet, because it says nothing about the height. So we'll call this H. That's your hint. Create your constraint based on the... Correct. Your constraint formula is going to be this. 3W times W times H equals to 50, because that's the formula for volume of a box. Now some of you ask me, so how do you know this is my constraint and not my max min? Because I want you to look for here, it says minimize, highlight this word, minimize cost. So my max min equation has something to do with cost, nothing to do with volume. That was the first part, done. The hard part is coming up with the max min equation. And it has something to do with cost. Let's see who can figure that one out. 2. So I want to hear. So this is your max min, right? So this is your max. This is your min equation. So you have 2. Yeah, bracket. 3W. Times W. Yep. Times 10. That's correct. The reason why is because it says, look, the cost of the top and bottom costs $10. So this is 10 times the surface area of top and bottom. Guys, continue on. Plus. I'll pause. 2 times WH, yeah? Times 6. Correct. But you're missing one more thing. Plus. 3W H times 6. Because there's 6 sides altogether. Sorry, what?
Because it's 4 sides, right?
No, because the reason why is these are different. This is WH, this is 3WH, okay? So now, this is too messy, guys. Hi.
For the second part, where it says 6 times 3 times 1, why is there no 2 on
Nope, sorry, someone forgot a 2. Because there's one in the back, yep. So this is too messy. I'm going to simplify this. Let's simplify this right now as 20, that's 60W squared. Very nice. Plus 12WH. Nope. Plus 12's 3 is 36, WH. 36WH. Look at my work, see if there's any errors with your work. Check. I can simplify this. And this becomes 60W squared plus 48WH equals to my min cost. There's my 2 equation. There's the constraint. There is the min cost. Now, I'm going on to the next step, which is I'm going to fuse these 2 equations together into one. A few minutes ago, I look at this equation and I say, hey, you know what? It's probably easier to get h by itself. So h equals to 50 over 3w squared. It's just easier to get it. So then I'm going to sub it in. 60w squared plus 48w times 50 over 3w squared equals to min, or equals to my min cost. Guys, take over and finish it from here. This is where all your derivatives kicks in and all your critical point. And notice the question is rigged. I'm asking you for min this time. The question is rigged in such a way that you always get a min, no matter what happens. Okay? This really becomes 60w squared plus 800 over w equals to cost. Let's see. So since I want the minimum cost, I'm going to take the derivative of this, which gives you 120w minus, here's the weird 800 over w squared, which equals to 120w cubed over w squared minus 800, okay, equals to C prime. If you did this correctly, now we're setting equal to 0, so you got w equals to cube root of 800 over 120, and that should give you roughly 1.88. Sub this in and you get your h. H is equal to whatever I have right there, which is 4.7. Your length, which is 5.6, and therefore your cost based on this dimension is $637.60. Voila. That is the power of calculus, guys. Try example 5 on your own without my help. And if you don't have that, I'm going to walk around and make sure you have it. So I'm going to pause. So if I look at number 5 is really asking for new things this time. It's very similar to what we did, but this time is looking for max volume. So in order to find max volume, what I'm allowed to do, I go, that's my max. So my box has a square base, so therefore it's going to be W squared H. That's the volume. Because it has a square base. My constraint, in order for you to do the constraint, it says you only have 10 square meters. So therefore the surface area of the whole entire thing has to be 10 square meter. I'll give you a hint. It'll be something plus something equals to 10. That's your constraint. Take a minute, figure out what the constraint is. Go. And anyone have the constraint? Soroya, what do you have? 4WH plus W squared equals to? One part is wrong. 2W squared because it's top and bottom. Okay? There's your constraint. The rest is easy, guys. So here's my box. This is W, this is W, this is H. The rest really. So if I were to look at this, the easiest one and the best only solution you can actually solve for is H. So H equals to, I'm going to do a lot of isolation, but what you should get and then for H is 10 minus 2W squared over 4W. There's my H value. I'm going to sub this into here. Okay? Go ahead, sub it in. And I'll give you a hint. You can actually sub it in or you can actually do something else to it. So think about what you can do with the H. Ruby, what can you do with it? Simplify. You can actually simplify this. See, 10 to 4. So this actually becomes 5 minus W squared over 2W. You can actually use either or. You get the same answer and then simplified version really gives you a slightly smaller number to work with. So I can either use this form or this form. The simplified form is probably a lot easier for you to work with. Guys, continue. So here's my next line if you're lost. I'm going to sub it in and this is what you should have. V equals to W squared times 5 minus W squared all over 2W, which equals to 5W minus W cubed over 2. That equals to V. Problem is that's only halfway there. We need to know what V prime is. Because the reason why I want to know what my max and min volume is. Take the derivative of this. And I'll let you continue on. Go. So if I take the derivative of this, you should have 5 minus 3W squared over 2, which gives me W equals to root 5 third, which is what you should have. Okay. Once you have W, you can easily get H. Once you have H, you can easily calculate the volume. And that's where I got this from. Okay. The issue now is number 6. That's where it gets a bit more challenging. Look at number 6. And this is probably the last one I'm going to do until we're going to hit our lunch break. Example 6. And I want to just load up example 6. And there's a twist with example 6. I want you to highlight a few key things. And they expect you to know this when you deal with it at university. I'm working with 1.5 liter. Highlight this for me, please. Okay. But notice that my answer is in cm. You need to know basic conversion from volume to centimeters. And what you're given is this hint. You're going to write this down on here. 1 ml equals to 1 cubic centimeter. Since I'm working with cm, I know that my unit must be in terms of ml. Okay? So 1 ml equals to 1 cubic cm. So in other words, once you use this equation, you're going to use 1500 ml. Okay? Because liter and cm doesn't match together. You got to work with mLs, not liters. Start your work. So, notice one thing, my max and min. When I talk about max and min, I'm talking about the materials used right here. Minimize amount of material, which means I'm referring to surface area. Some of you forgot your formula for surface area, so I'm going to give you a formula. It's going to be 2 pi r squared plus 2 pi r h. Now my constraints, see, I hold 1.5 liter, so my constraint really has to do with volume. Constraint is going to be volume, which is pi r squared h equals to 1500 ml. There's your two equations. Figure out what to do from there. Go. If you're lost, I notice I'm going to solve for h. That's probably the best one to solve for. So it's 1500 over pi r squared. Sub this into here. So what you get is psi equals to 2 pi r squared plus 2 pi r times 1500 over pi r squared. So what you should be left with is 2 pi r squared plus 3,000 3,000 over r. Okay. So look what I did. If I take the derivative of this, you should get SA prime equals to 4 pi r minus 3,000 over r squared, which will give you 4 pi r cubed minus 3,000 over r squared. Solve for r for me. And if you did this correctly, you should have r equals to cube root of 3,000 over 4 pi, which will give you roughly 6.2 cm. Once you have this, you can easily find h and find the rest. All cylinder question works on the same concept. Your work for today: